Greetings, Affinicionados. The message you see on the top of your screen is greetings. We are going to encode this message using the Affine Cipher. So first, we replace each letter with the number that gives its position in the alphabet. For example, G is the 7th letter of the alphabet, so we replace G with 7. And R is the 18th letter of the alphabet, so R gets replaced with 18. Repeat this process for every letter in the message. Take all of these numbers and multiply them by some number. Here we have chosen to multiply them all by 3, although there are other choices that we could use. However, even numbers do not work very well. So 3 times 7 is 21, 3 times 18 is 54, 3 times 5 is 15, and so on. Then choose a number between 0 and 25. Has to be between 0 and 25 as there are 26 letters in the alphabet. Add this number to everything. Here we have chosen to add 10. 21 plus 10 is 31. 54 plus 10 is 64. 15 plus 10 is 25, and so on and so on. And then divide everything by 26 and take the remainder. For example, 31 leaves a remainder of 5 when divided by 26, since 31 is 5 more than 26. And 64 is 12 more than 2 times 26. Repeat this process with all numbers. Once this step is completed, you should only have numbers between 0 and 25. And if you look at the 4th row of numbers there, that's exactly what you see. The numbers are 5, 12, 25, 25, 18, 11, 0, 5, and 15. So all of those are between 0 and 25. Now, if you had any zeros, they should be replaced with 26. So we see the third column from the right, we had a 0. We have replaced that 0 with a 26. We have not changed anything else. So all of the numbers should now be between 1 and 26. So they match up with a letter from the alphabet. Replace each number with that letter. So the 5th letter of the alphabet is E. The 12th is L, and so on. So greetings has encoded to E, L, Y, Y, R, K, Z, E, O. When you use a multiplier of 3 and an adder of 10, the number added in this case is 10, is called the Caesar shift. Now here are the possible multipliers we can use. Each of them has a partner that can be used to undo the multiplier when decoding the message. The table tells you that multiplying by 9 when decoding can be used to undo a multiplier of 3 used when encoding it, and multiplying by 21 when decoding can be used to undo a multiplier of 5 used in encoding. So that will be useful to us when it comes time to decode a message. And let's now have a look at decoding ELYYRKZEO. We just encoded the word greetings to get this, so we know that our answer should be greetings. But let's have a look at the process of decoding this message. So first, change all of the letters into the number corresponding to their position in the alphabet. So E is the 5th letter of the alphabet, L is the 12th letter of the alphabet, Y the 25th, and so on. Now we first need to undo the Caesar shift that we used, the Caesar shift of 10 when we were encoding the message. So we need to add 16 when we are decoding the message. Note that adding 10 and then adding 16 has the same effect as adding 26. And since there are only 26 letters in the alphabet, adding 26 is the same as going through the whole alphabet and getting back to where we started. So adding 16 when decoding will undo the effect of adding 10. In general, adding 26 minus x will undo the effect of adding x. So to use another example, since 26 minus 5 is 21, we can add 21 when decoding to undo adding 5 when encoding. We now need to undo the multiplication of 3. This is when the multiplier and partner table from just before comes into play. As a multiplier of 3 has a partner of 9, we will undo the multiplication by 3 by now multiplying by 9. So 21 times 9 is 189. 28 times 9 is 252. 41 times 9 is 369. 34 times 9 is 306. 27 times 9 is 243. 42 times 9 is 378. 21 times 9 is 189. And 31 times 9 is 279. Then we take the remainder when dividing by 26, just like we did when encoding. And there are no zeros there, but if there were any zeros, we would replace those zeros with 26. So what we have is a row of numbers that are now between 1 and 26. So before we replaced any zeros with 26, we would have had numbers between 0 and 25. But replacing those zeros, if we had any, with 26 gives us numbers between 1 and 26, and therefore they correspond to letters of the alphabet. Now again, we replace each number with the appropriate letter from the alphabet. So the 7th letter of the alphabet is G, the 18th letter of the alphabet is R, and so on. So we have got back the original message, greetings. So how does the Affinicionado challenge work? You are given 2 letters of the decoded message. From this, you will need to figure out the multiplier used in encrypting the message. Here, the 2 letters of the original message we are given are R and I. R is the 18th letter of the alphabet and I is the 9th letter of alphabet. As I comes before R in the alphabet, we need to add 26 letters to I so that the left-hand letter comes before the right-hand letter in the alphabet. So I being the 9th letter of the alphabet, we add 26 to get 35. So R is the 18th letter of the alphabet, and we are treating I to be the 35th letter of the alphabet. Now, that means that the 2 letters are 17 apart, since 35 minus 18 is 17, and that means that the 2 letters are 17 apart in the alphabet. Now, this is in the decoded message, so we call that the decoded spacing, or D space, and D space here is 17. Now, we see that R got encoded to L and I got encoded to K. So let's look at those two letters, L and K. L is the 12th letter of the alphabet. K is the 11th letter of the alphabet. Now, K is before L, so that means we need to add 26 to K, and we are therefore going to treat K as the 37th letter of the alphabet, which puts the two letters, L and K, 25 apart. So these two letters are 25 apart. Now that is in the encoded message, so the encoded spacing, which we are calling N space, is 25. Now we need to work out N space, which we just found to be 25, divided by D space, which we found before to be 17. 25 divided by 17, that's not a whole number. So we need to add 26 to the top number, so we need to add 26 to 25. Always adding 26 since there are 26 letters in the alphabet. 26 plus 25 gives you 51. And when we divide that by D space, which is in this case 17, we get 3, which is a whole number. And furthermore, that value of 3 is our multiplier. So we've worked out so far that the multiplier used is 3, and the partner of 3, going back to the multiplier partner table, underneath a multiplier of 3, we see a partner of 9. So 3 has a partner of 9. Now we need to find out what number was added. R we know to be the 18th letter of the alphabet, and we have also found that the multiplier is 3. So 3 times 18 is 54. Now dividing that by 26, and we get a remainder of 2, and the second letter of the alphabet is B. Now we need to get to L. We need to get from B, the second letter, to L, the 12th letter. So the difference there is 10 letters, and we need to go forward 10 letters in the alphabet to get from B to L. So that tells us that the number added, or the Caesar shift, is 10. But we didn't need to get 10 from R. We could have also used I to get 10. So we've got the choice of the two letters that are given to us. I is the 9th letter of the alphabet, and the multiplier used is 3. Work out 3 times 9. That gives us 27, and if we divide that by 26, the number of letters in the alphabet, we get 1. And the first letter of the alphabet is A. To get from A to K, which is the 11th letter of the alphabet, we need to go forward 10 letters. So again, that gives us a added number, or a Caesar shift, of 10. Now, as the number added when encoding is 10, that's what we've just worked out. We can undo this by adding 16. Now, remember that 26 minus 10 is 16, and we're undoing that addition by 10 by adding 16. So 5 plus 16 is 21. 12 plus 16 is 28. 25 plus 16 is 41, and so on to work out the second row of numbers. So we have undone the Caesar shift by adding 16. Next comes the undoing of the multiplier. So to undo a multiplier of 3, we need to multiply by the partner, which is 9. So 21 times 9 is 189. 28 times 9 is 252, and so on to work out the third row of numbers. Then we need to take the remainder when you divide by 26. So 189 has a remainder of 7 when you divide by 26. Now, it is possible at that step to get 0, so that row should be numbers between 0 and 25. But if we do have any zeros, they need to be changed to 26 so that we get numbers between 1 and 26, and they will therefore correspond to letters of the alphabet. Replacing each number with its letter, so replacing 7 with G, replacing 5 with E, replacing 20 with T, replacing 14 with N, and replacing 19 with S gives us back our message. So we have cracked the code, and we have found that the original message was greetings. So that's how the Afffinecionado challenge works. Thanks for watching. Happy Afffinecionadoing.